In this lesson, we'll be considering accuracy and precision. As a motivation, let us look at two cases. Now, look at these three statements. Jill has 15 marbles. Mark baked 2 dozen muffins, and John is 173.2 centimeters tall. So, question, is the 15 an exact or an approximate number? 2 dozen, is that approximate or exact? 173.2, is that approximate or exact? As we'll see, the 173.2 is approximate. All measurements are approximate, and we'll have to consider how to treat or round approximate numbers. That will be one of our considerations. Now, if we look at the second case here, v is 1/3 pi r squared h. Well, clearly r and h are measurements, so they are approximate. If we are using them to find v, then clearly v itself has to be approximate also. So the question becomes, how do we round v? Do we keep all the decimal places? Do we keep some? If so, how many? So it leads to the question, how do we round approximate numbers used in a calculation? And these are the things that we'll be considering just now. Exact numbers are numbers that were determined from either counting or by definition. So, definition is a dozen is 12, exactly. Counting, John has 15 marbles. That's exact if you count it properly. So there is no uncertainty in exact numbers. What are exact numbers again? Numbers derived from counting or from definition. Okay, so here we say John has 15 marbles. That's exact. Mary baked 2 dozen cupcakes. That's also exact. Now, approximate numbers are derived from measurements. All measurements are approximate, and there is always uncertainty in approximate numbers or numbers derived from measurements. As an example, Tom is 178 centimeters tall. Now, can you see a unit attached to it there? That's a measurement. So that is approximate. Another case, the cake. Yes, I'm in a cake mode today, cupcakes and cakes. The cake weighs 3.24 pounds. Okay, so that's also a measurement. So that has to be approximate. Now we have to learn how to deal with approximate numbers, and we'll be considering rounding, and we're also going to be considering significant digits, and we're going to be first of all looking at how do we count significant digits. That's going to be very important. Let me just say at this point that many of the concepts that we'll be looking at may seem a bit disjoint, but trust me, towards the end, it will all come together. So let us now look at counting significant digits. So there are 5 rules here that we'll consider. The first one is that all non-zero numbers are significant. So 1 to 9 would be significant, but 0 sometimes significant, sometimes not. And we'll see when it is, when it isn't. So number 1 here, 345.98. All these numbers are non-zero, so there will be 5 significant digits. 1, 2, 3, 4, 5. Second, all zeros located between non-zero numbers are also counted as significant. So in this case, 3450.087, these zeros are located between 5 and 8, which are significant. Hence, the zeros are also significant, making this number 1, 2, 3, 4, 5, 6, 7 significant digits. Third, zeros to the left of the leftmost non-zero number are not significant. They only serve to locate the decimal point. So in this case, these zeros are to the left, so they don't count, and we have only 3 significant digits. Number 4, trailing zeros in decimal numbers are significant. So as long as there's a decimal point, numbers to the right would be significant. So we have 1, 2, 3, 4, and 5 significant digits, and this has only 4. The last one. Now, a number like 98900 would normally have 3 significant digits. If we know that this 0 is significant, then we put a bar over that. So in this case, now it would be 1, 2, 3, and 4 significant digits. If we had like 98900, then this now would be 1, 2, 3, 4, and 5 significant digits. This 3600, there's no bar over any of the zeros, leading us only to 2 significant digits. The next thing we'll be looking at is how to round numbers. Just looking here, we'll see what we mean by tenths, hundredths, thousandths, and 10,000ths. So if we're rounding to the nearest tenth, we only keep 1 decimal place. Hundredth, we're keeping 2, and thousandths, 3. These 2 examples you'll see in your solutions posted on D12. So there are 3 rules we'll have to consider when rounding. The first 2 are very straightforward. The third one, well, you'll get used to it. The first one here. We're rounding 6.7647 to the nearest hundredth. So identify the hundredths place, which is a 6. What you do, you look to the right. If the number is less than 5, we drop all the digits following the 6, the hundredths place, and that's it. So this is rounded to 6.76. That's it. The second case, we're also rounding to 2 decimal places. That's 5. So we look to the right. If the digit to the right is bigger than 5, then we increase the digit we're rounding to by 1. So this becomes 6.46. Because the 7 is bigger than 5, we increase the 5 by 1 to give us 6.46. So we consider 2 cases: when the number to the right is less than 5 or when it is bigger than 5. Now the question becomes, what happens if the number is equal to 5? What do we do in that case? Okay, well, let's do this one. So we are rounding to 2 decimal places, which is a 6. Okay, the number that follows is a 5. Now you have to ensure that no other number follows the 5. All zeros. So this is 6.765. The number that follows the 6 is a 5. So now the rule applies. There are no other numbers following the 5. So you look at the number that you're rounding to the 6. Because the 6 is even, you leave it as it is. You drop everything, so it becomes 6.76. Now the second one is different. We are also rounding to 2 decimal places. So we look to the right of the 2, we see a 5 followed by a 0. So the 2 conditions are satisfied. There's a 5 and no other numbers following. No other non-zero numbers. So you look at the 7 you're rounding. Now 7 is now odd. So if this number is odd, you increase it by 1. So it becomes 6.78. Let's look at 4 problems here. And they are sometimes problematic for some students. So let's get this out of the way. Round 523 to one significant digit. So one significant digit you start from the left would be the 5. So some students would put 5 down, but that's not correct. If I owed you $523 and you say, well, round it to the nearest 100. If I gave you $5, I'm sure you would be very dissatisfied. The answer is actually 5 followed by 2 zeros, 500. Round 523 to 2 significant digits, so 1, 2. So the answer is 5, 2, 0. Okay. Round 1765 to 1 significant digit. Again, you look to the right, it's bigger than 5, so you increase the 1 by 1. So this becomes 2, and don't forget the 3 zeros. Round to the nearest 1,000. Again, that's 1,000 there. To the right, it's a 4, it's less than 5, so this just becomes 3,000. Okay. We'll be looking now at 2 important concepts, that of accuracy and precision. Accuracy refers to the number of significant digits, whereas precision refers to place value of the last significant digit. So it's very important to study these 2 definitions here. A number is said to be more accurate if it has the most significant digits. And a number is said to be more precise if it has the last significant digit in the smallest place value. So let's look at this. 39.00 in terms of, let's look at accuracy first. So accuracy is significant digits. So this has 4 significant digits, then 3, then 2, then 1, based on our earlier lesson on counting number of significant digits. Now precision. 39.00 is precise to the 100th, because this 0 is significant and it's in the hundredths place. Now this is thousands, because this 0 to the right is in the thousands place. Now the 7 is significant, so now this is in the hundreds, and here the 5 is in the thousands place. Okay, so you could verify this, that the least precise measurement would be the 4,700 meters. The most precise would be 0.850 meters and also 0.005 meters. The least accurate would be 0.005, and the most accurate would be 39.00 meters. Okay, so this is a moment we have all been waiting for, where everything all comes together, where we're going to be doing a calculation and rounding our final answer based on accuracy or precision. So the question is, when do we round based on accuracy? When do we round based on precision? So here are the rules. When we have a calculation to do, we use the rules of BEDMAS, or order of operations. So there's always a last operation to be done. That will be either adding, subtracting, multiplying, or dividing. If our last operation is addition or subtraction, we round based on precision. That is decimal places or place value. When our last operation is either multiplying or dividing, we round based on accuracy or the number of significant digits. And we round our final answer based on the least precise or least accurate of all the numbers that went into that calculation. So let me do 2 examples here for you. All right, so we're multiplying. Now assume that all these numbers here are measurements. So we have 3.967 times 2.84, and the answer here, if you plug it in your calculator, is 11.26628. You could verify this. Now, what's our last operation? Well, there's only one operation, which is multiplying. So when we're multiplying or dividing last, we base on accuracy or significant digits. So this number has 4 significant digits. This has 3. So 3 is less accurate than 4. So we need to go with 3 significant digits. So our answer therefore is approximately 11.3, because we look to the right, bigger than 5, we increase the 2 by 1, so it's 11.3. Likewise, the second example, if we just do the division straight off, we get negative 1.698239. Now again, last operation is division, so we round based on accuracy or number of significant digits. This number has 3 significant digits, this has 4, so 3 has the least number of significant digits, so we round to 3, so it's negative 1.70. We are going to 3. 1, 2, 3. Look to the right, it's bigger than 5, so we add 1 to the end, it becomes 7 and 0. Okay. And let's look at 2 other examples. Now we are adding and also subtracting, adding and subtracting. So when we're adding and subtracting, we are rounding based on precision or decimal places. When we do this calculation, we get 6.809. Okay, this goes to 3 decimal places, that goes to 2, so 2 is less, so we go to 6.81 to 2 decimal places. Again, second example here, the answer is negative 7.357. Again, this has 1 decimal place, 3, so we have to round to 1. So it's approximately negative 7.4, and that's to 1 decimal place. So that's about it. If we have a calculation with more than 1 operation, for example, 3.76 minus 5.128 multiplied by 0.1, so this would be our example 3. Well, we would do the brackets first, then the multiplication. So our last operation would be multiplication. So when our last operation is multiplying, we round based on accuracy or the number of significant digits. The least number of significant digits would be 1. So our final answer would have to be rounded just to 1 significant digit. Okay, happy studying, and we will see you in the next class.